So the request from Brian was to discuss mechanics of writing, and his background. Yeah, I literally have taught courses on writing at the undergrad and the grad level, and everybody who's in the group knows that I'm just a little bit passionate about writing, and and the justification I get for that is students and former students remind us, especially former students, remind us again and again how important writing is as a skill. So there's a part to writing that's composition, structure, wording, all sorts of stuff. And again, we could talk for hours on that. But what Brian asked me to focus on was a little bit more of kind of the mechanics, because this can be a shift for students who haven't seen this type of writing or this way we have of writing. And I realize now I forgot to dig up the history slide that would explain kind of where this system comes from, because while it may be new to some or most of you, it's absolutely not new, and we'll get into that. The basic message is that there's a way to write that you've all done. I would guarantee that, and that's using a program like Microsoft Word or something that's like it in the sense that you kind of type, and as you type, right away you see the product of that typing. You see something reasonably similar to the finished document while you're typing, and that's got a name. We'll come back to that. And I'm going to try and explain another way of thinking about writing, which comes out of computer science and comes, in fact, from one of the legends of computer science, a guy named Don Knuth, who's written many textbooks on computer science and really helped define the field, one could argue, because computer science didn't always exist. I mean, it came out of different areas. In our university, it actually came out of mathematics. It was kind of a bunch of applied mathematicians who got tired of being looked down upon by their pure math colleagues and wanted to actually use math for something, which is completely crazy, of course, to actually use math for anything. It's sinful, exactly. So they were kind of the origins of the department. And Michael mentioned that there was kind of an important graduate from that department, that computer science department, and it's the W in the Warnick Engineering Building. So the person you're talking about is John Warnick. John Warnick was a graduate of computer science, and he wasn't one of the founders of the department, but was one of the early members, and he went on, as did an incredible number of that first sort of generation of mostly graduate students in computer science, and they took this ethos of taking math, taking ideas out of physics, and turning them into something that has impact, and they arguably have had just an astounding impact, Adobe alone, but many others that I can tell you about some other time. So now I want to focus back on what we're talking about here. So we're talking about a program that's called LaTeX. So this is not LaTeX. This is not meant to be the rubber-like substance. The T is a tau. The thing that looks like X is meant to be chi. So it's sort of a weird riff on Greek letters, and it's kind of typical of the quirkiness of computer science. So, for example, the origins of LaTeX are really, in language, the original language that Don Knuth made was called TeX, so just these three letters, TEX. And he decided that the version number of TeX would asymptotically approach pi. So there will never be a version 3.15 of TeX. It's not allowed. And so again, there are odd, quirky things about this whole system that will come out that really are just quirky, and others make sense. So Leslie Lamport took the basic mechanisms in TeX and put his initials in front of them, or the first of his last name, and created this thing called LaTeX or LaTeX. And there's lots of arguments how you say it. Doesn't really matter. But the point is, it's a more accessible version. Not even really a version, it's a wrapper really around TeX. And that's another pretty typical thing that computer scientists do. They take core functionality and then they build wrappers around it to make it more accessible. And LaTeX fits that model very well. And the key sort of rationale for doing all this is what this graph is meant to capture. And on the x-axis, you see it has document complexity and or size. Often they go hand in hand. As you start to write larger documents, they tend to get more complicated. Complicated in the sense that they have many references, for example, they have many figures, and they also refer to each different parts of the document. So in one chapter may refer to another chapter, and certainly would refer to figures, by their figure number, so all these kind of elements add a lot to the challenge of mechanically writing a document. So these two things tend to go hand in hand, and as you move from left to right along the scale, then things change. I mean, writing a one-page letter is totally different from writing a 200-page PhD thesis, and not just because the content is more larger and harder to get your head around, but just in terms of the document itself. And on this axis, you have effort and time consumption. So in a perfect world, of course, you want to be down here. You want to be as low as possible on this y-axis, independent of how much the document gets big or gets complicated. And the premise, and there's lots of data to support this, is that a program like Word, I'm going to pick on Word, but it really is any editor like it, that it has, and when a document's small, it's kind of got a low effort index. But as the document gets larger and more complex, then that effort just takes off. I mean, here it's sort of approximately, I don't know, asymptotically or whatever but the point is it takes off very steeply. So it has some already here sort of some steepness, but it doesn't take much of a document before Word can get to start to do really weird things. And you'll find you really don't know how to put that figure where you want the figure to go, or how to automatically keep track of figure numbers, or lots of other elements that LaTeX is really good at. So the idea of LaTeX, or the consequence of the way LaTeX is structured, is that it has a higher point of entry in terms of effort and the time it takes to make your first LaTeX document, at least one you make from scratch, but that the curve stays flatter a lot longer and has a much less steep slope. So that even as complexity and size increase, the effort and time consumption stay lower, substantially lower than a program like Word does, and that's the basic premise. So yeah, it's going to feel weird in the beginning. It's going to this entry point is higher for sure, but it is one of those tools that doesn't climb nearly as quickly as the document gets bigger as you go along. So, and as a brief sideline, I want to sort of bring this up. And Michael mentioned Adobe, and this will harmonize in just a sec. So how do we do writing together? This is another sort of whole topic. I'll hit it from a couple of different sides, kind of in brief summary here. But we oftentimes have, we want to write together, we don't have to write together. You as students may not have a choice sometimes, but in practice, whether you're in a scientific group or an engineering group or any kind of group, then sharing information is important, but also collectively gathering that information and organizing it and writing it up together, is an ongoing task. Everything happens in teams, research is in teams, certainly R&D happens in teams. So, so how do you work as a team together? And there are different ways to do documents as a team. And I'm just going to put a brief plug in here for this notion of, PDF markup. Markup in general is a concept you've seen before. Word has it. It's where you make suggestions. You write a new version of the sentence in a document, and it lives there, and it's marked as a suggestion. And this is generically a good thing. And oftentimes students, especially grad students, would struggle because their mentors would just dive in and rewrite things. And that's not really pedagogically very useful nor very satisfying. And so markup or anything like it feels like these things are coming at you as suggestions. And I've heard, many students say that, editing, just having the document edited feels a little bit like punishment. Your writing mentor, your supervisor is just beating you up by rewriting everything you've carefully written. So, and PDF is one way to do that. And I just want, to make you aware of that as you go through your own academic and subsequent careers, that PDF markup's kind of an interesting compromise. And as we heard from Michael, Adobe tools are freely available to us. There's some good markup tools in that set. Here's the Premiere Pro that he used to make his video. There's a whole set of cool tools. It's all part of this thing that Adobe calls the Creative Cloud. And if you have not secured your license for this, go to the Office of Software Licensing, and they'll give you instructions on how to do this, and you can really get it all for free. And these are thousands of dollars worth of tools. One of which is Adobe Acrobat, either as a reader, which is free, or as the pro management tool. And so this is a great way. Both these are pretty good ways to do markup of PDFs. So don't hesitate if you're working together with somebody, or asking somebody when you have something you want their input on, to take it as a PDF, mark it up, and send it back to you. Okay, so that was just, like say, more or less an aside. And just again, as a significant, in some cases, additional aside, the Windows and Office tools are also freely available. So we have great software licenses for these, which you'll really learn to appreciate when you head off into the real world, or actually go look at what these things usually cost. All right, so writing tools, let's get back to this. So again, the premise here is that LaTeX is a good tool. Anyone know what this word means here? There's an acronym.
Yeah, that's what you see is what you get.
Very good, very good. So these are called, Wysiwyg is what we sometimes call them. And so all these editors, like Word or Pages or a bunch of others that have existed in history, they all have this same behavior that supposedly what you're typing and what you see in the document is what you get. LaTeX is fundamentally different from that and has a whole different way of going about it. So if you can actually do a Google search on word rage, and with a little searching around, you'll find some tools by a guy I'll show you in a second, who talks about the anger that we sometimes feel when we're using a tool like Word and trying to actually do some real writing with it. It's sort of related to death by PowerPoint, but only Word does too much, and it does it without asking you. So this is kind of a summary of, I think, what frustrates most of us about Word is it'll suddenly start indenting when you didn't actually tell it to indent, or it'll start making lists when you didn't tell it to make a list, or you start moving a figure around and it suddenly disappears and reappears on some other page. And this is the problem that many people have. And this is to give Microsoft credit, and I think Pages does it perhaps even a little softer and a little more predictably, is, it used to be that you could move one thing and really mess up a whole document. And I've been through this firsthand with older versions of Word where figures would quite literally disappear. We'd be busily moving a figure to get it in the right place on the page, and it would just go and it'd be gone, and we couldn't find it again, and we had to go sort of reinsert it, and all sorts of horrible things. So and this is, I think, a great summary. It always feels like you have to trick Word into doing what you want, and that's arguably not a great tool. If you took that logic and applied it to the way a wrench works or any other tool you use, you can imagine the source of frustration. So James Hayton is the guy who put all these ones together. He continues to write. I don't know if any of you grad students follow him, but he writes a blog on writing a PhD. He's done with his now, but he sort of shares his experiences and wisdom on an ongoing basis, and I think makes a small living out of that, as well as his actual science. So how do we solve that problem with LaTeX? And the way LaTeX did it was, again, it's a very CS-y sort of way of thinking of things, and it separates the writing from the document creation. So writing is an act. Writing is a way of finding words, putting them in the correct order, organizing them carefully to convey a meaning, and it has enormous challenges. Writing well, it takes a lifetime, I think most people would say, and if you read up on any of your favorite authors a little bit and find what they say about writing, they'll have all kinds of sometimes horrific horror stories about how hard it is, but what they will all say is that they write 4 and 5 drafts, full complete drafts of that latest crime novel or whatever your favorite genre is, before they even give it to an editor to look at. So writing is just hard, and because it's hard enough, why in the world would you want to, at the same time as you're doing writing, be worried about something like document creation, which is a separate process? So document creation is, how do I organize the text, the fonts, the margins? How do I insert the figures in the right place? How do I keep track of those figure numbers and section numbers and citations and references and bibliography and all those kind of things? And so LaTeX and tech before it, really came from the perspective that we should think about writing and focus on writing, and then we should think about document creation, and we should do that as a separate process. And so that's really, so whenever you think, why are they making me do it this way, even when you're frustrated a little bit, I think if you see it in this context, it starts to at least make some sense as a consistent way of thinking about this. The other thing, being a computer scientist, it was easy for Don Knuth to say, I don't want to think about stupid stuff. I don't want to think about numbering my references. I don't want to think about keeping track of, whether figure 2 is still figure 2 because I've inserted a couple of more figures before it. This is stuff computers should keep track of. We should not be ever having to worry about this kind of thing. So we wrote it with that in mind. It should also support a clean structure, and that's really, when you think about writing, and at some point you have to dump those words into a file. Having a clean structure to that file arguably makes the whole process at least less error prone, and at least somewhat easier to communicate with others, share with others, work together with others on. And the sharing is an important part of things that as I said, we almost always these days are in some way writing together. Even that sole novelist sitting in a room somewhere on the in Paris doing the writer thing, at some point has to share their writing with an editor, and it becomes some kind of a team project at that point. So in science it's way more extreme than that, in that we do virtually all our writing in groups. So you want to have something that's easy to share and easy to manage, and again, LaTeX I think does a good job on that. And this is, Michael, your comment about ski run is a great segue into this notion that when you have things that you do repetitively, that, small steps that you can sort of that can group together and just reuse with a slightly different input, you could argue that's what programs do, right? I mean, we write programs, and Nate showed us, you write a program so you can just give a different input and it will do the same thing over again for you with that different input. And why not have writing tools that will do the same thing? So with Word, you take it the way they deliver it, and if you want to replicate it, you copy and paste and hope it doesn't break anything, and then you go back and fiddle and update and correct and customize. Whereas LaTeX, the idea is it's like a computer language, which you can actually extend yourself as a user. And what they put together they call packages, and that's beneficial as a user when you have something you really want to have automated, just like you would in any program. But what's really practical is that chances are really good if you've had a problem with some task that's a little quirky or difficult or repetitive, someone else has too. And you'll find a package out there. So there are, just like with Python, other, MATLAB, other popular computer languages, there's an amazing number of software tools out there that are based on LaTeX and Tech that are freely accessible. And I should say that from the start, LaTeX has always been an open source project, and it's never been sort of fundamentally commercialized. I hesitate a little bit because there are some other pieces to this. And the last thing is that visible markup is more powerful than hidden smart commands. So one of the reasons that Word can be so confusing is that it's doing stuff behind the scenes. It's trying to think for you, which is also disturbing. But even when it does, it does something, like it creates a list or indentation or something. It has all these smart hidden commands, which you can visualize. I encourage you to do that. It's not that it will help clarify much. They're very confusing commands, but you can in Word actually visualize those markup commands. And there's times when that's the only way to figure out why Word is doing what it's doing. Again, Tech and LaTeX took the other perspective and said it's a programming language, and so in a programming language you don't hide stuff. The source code is the source code. When you look at a MATLAB program, there's nothing hidden there. It's the MATLAB commands are visible, and so why shouldn't the commands that you need to do writing? And there are tons of examples besides the obvious ones of weird and wonderful things that people have done with LaTeX that these are all examples of things that were done with LaTeX, packages out there. So there's, I'm sure more than one chess package out there where you can write down your chess moves and do music. I mean, there are music programs for composing things. There are even programs that have graphical elements like this for making circuit diagrams, or maybe more importantly, chemistry diagrams. So there's really extreme examples of LaTeX being used for all sorts of stuff because it's been around for 50 years. So while again, you may have only heard of this for the first time, I think the first time Knuth published the first version was in something like 1973 or something. It was early 70s. So, it's been around for a long time. It's just not new. And there's been a lot of time for people to put together really, really cool packages. So that's probably a good place to stop before we get into the mechanics. But hopefully that'll motivate you, a little bit to think about how writing can be different from Word, and we'll get back to the mechanics of it. And the key thing to remember is to think about writing in LaTeX, kind of like writing in a compiled computer language. Well, some of you haven't even been exposed to that yet because you've lived in a MATLAB, Python sort of world. But older computer languages, and still C and C++, arguably some of the most powerful ones, some various versions of Java, are compiled languages, and that you write the code, you develop the code, and you have all your algorithms implemented. Then you do another step, and then you get a functioning program that you can give to somebody. And MATLAB can work that way. You can take MATLAB code, turn it into a executable, and give that executable to somebody to operate. And they never will see the source code. All they'll see is a finished program. And there's something really clean and simple and nice about being able just to deliver a program to somebody rather than delivering them a whole bunch of source code. And it's the same with the document. At the end of the day, you want to deliver a PDF, but when you're writing that PDF, making that PDF, there's times when it's really useful to think about it in a different way, to think about it in terms of just writing, and then to think about document creation as a separate step. So like I said, I think that's a good line to draw for today, I think.
One thing to give some context in terms of the, I think you called it the entry point, or the break-even point between trading off between Word and LaTeX. What would you say? I have my own threshold, and I'm curious to hear what yours is, Rob, in terms of because I know obviously not Word, but Pages is your go-to for some documents. Yeah, so at what complexity do you switch to LaTeX?
Yeah, I mean, the history that most people go through, and I'm certainly one of them, is the first time you do a really big, complicated document is when you're kind of tempted to take the plunge, especially if there's somebody there to help you. We'll come back to this, why learning LaTeX and sharing a LaTeX document with somebody else, literally in the form of a template, is much more powerful in LaTeX than it is typically in Word. So my first conversion was, I was partway into writing my PhD thesis and using a program that I don't know if any of you have ever heard of, called WordPerfect. And it should be familiar to, because it was a Utah product, actually. It came from Orem, Utah. And
Rob, my grandpa's office is in the same building. And there's a big plaque that says location of the WordPerfect. Yeah.
So arguably, there's a couple things you should know being in Utah. One of them is John Warnick. And the other is WordPerfect, probably. But there's a lot of computer science that came out of here. But anyway, WordPerfect was what I had, and it doesn't take very far into a thesis to realize, oh my God, this is so painful. And then if somebody comes along and says, oh, here's how I did my thesis, and you just do it this way, and you just do it that way, and you just, all those references, just put them in here, and just do this and just do this. And so I wrote my thesis using WordPerfect as the editor, but I wrote it using the LaTeX language, because at the time I liked the WordPerfect editor. I thought the way I could reassign keyboards and do some customizing was really pretty cool. And so that was the actual editing tool that I used. And that brings up another point about LaTeX, is it doesn't really, just like with MATLAB, you can take, we all use MATLAB in the MATLAB environment, right? Because it's handy, it makes total sense. But you could take that MATLAB.m file and export it and edit it with Word, literally, if you want it. And as long as you save it as a text document, which is just characters, no formatting, as long as you save it as a text document, MATLAB does not care how it gets created. And then you just, you can paste it back in, you can just open it. You can write that .m file using some totally different editor and just open it, and MATLAB will read it just as happily. It doesn't care. And LaTeX is the same. So if you decide you wanted to use the MATLAB editor because you think it's such a cool editor, you could write LaTeX in your MATLAB editor and it would still work.
Done it. I've done it to make tables.
Yeah, there you go. So it's it's sort of a beautifully simple, flexible concept that gives you so much control. So So anyway, come back to your question, Wilson. So I started with the thesis because it was big, big, horrendous document, and then as time has gone on, the for me the cutoff point is sort of, shrunk, I guess, to the left in terms of that axis, that x-axis. In that now I write every letter. Every letter I write to somebody is written with LaTeX. And the only time I actually use something else is when I know I'm going to have to, let's say, copy and paste text from into a window with continuous scrolling kind of thing going on, that sort of stuff. So if I know it's really just simple copying and pasting of text, I'll sometimes do it that way. But no, virtually anything that I would say is a real document, you can do anything in LaTeX. I mean, there's no fundamental limit to it. So it just depends on your motivation and how much fun you have with it.
Yeah, I was gonna say, like, my rule of thumb, it tends to be if there's anything more than a single figure or a single page, I'll tend to do it in LaTeX. But even like when you mentioned letters, when it comes to cover letters for journals, because there's signatures and headers and boilerplate, I then also use LaTeX. So even that isn't a perfect threshold. But if I'm writing just an abstract, it'll just be Word. But if it's anything more complicated than that, then yeah, LaTeX.
Yeah. And that's the beauty of these templates. So the reason I write letters that way is that I just think about the contents of the letter. I don't worry about the signature, the letterhead, the format, any of that stuff. I just write the damn letter, and then I just push a button, and out comes a PDF file that's all formatted and pretty with my signature and my letterhead and whatever I want, because I have a template. And once you create the template, then it's just easy to reuse it with the actual content. Okay.
So if you couldn't tell, getting Rob to read something, you'll be far more successful if you send it in the text format or as a PDF.
Or as a PDF. Yeah.
I'm actually quite worried. I have given Rob the Iacocca protocol to edit in a Word document. I think I don't know what's going to happen, quite frankly.
I'm not sure. I haven't mustered the courage yet to open it, but I promise I will give it a try.
See, there's a huge barrier of entry. You see that? Everybody just heard it, right? Like, he has to muster courage to open it.
It's also an Iacocca protocol that requires a different kind of courage of its own.
Well, I mean, I think I'm probably safe in saying I'm the only one on campus that took that Iacocca protocol form apart, and there is a Word part, which is Word because they're forms, they're like lines you have to fill in. And it's just, it was too tedious to replicate all that. But then there's a big section where you actually describe the science, where most of the actual words go. And I pulled that out and made a LaTeX document out of it, and then would reconstruct the whole thing as a PDF. And I've done this for years and years. But there was a time when Iacocca said, "Oh no, we don't like it that it's it's not being done in Word." And I said, "Well, what do you mean? I'm sending you a PDF file. Why should you care?" And they had to back down. They said, if Iacocca is about the format of the file I submit, then there's something really wrong with Iacocca, because Iacocca is supposed to be about protecting the rights of animals, not about telling scientists how to write or which tools to use for writing. So I've had a few of these kind of fights over the years. I'm probably also one of the few people in the world who does their NIH BioSketch in LaTeX, because I got sick and tired of trying to do those in Word, and I do half a dozen of those a year, and it was just too painful trying to make those work in Word. And so I said, fine, and I made a LaTeX formula and a template, and I've been using it for, I don't know, the better part of 10 years.
Awesome.
All
Thanks,
right.
Rob. I appreciate the discussion. We will schedule another session in the near future.